You're hanging with Hussick. Again, this is another quantitative chemistry question. It's like about the third example we've gone through, but it's a titration question from a set of questions I gave you. And here it is. So it says titration is a chemical technique, talks about that. We haven't discussed titration too much yet, but we will when we do the topic of acid-base chemistry. But basically it's taking a solution of known concentration and adding it to a solution of unknown concentration in order to analyze it and try and determine something about the unknown. So the question here says that there's a 0.26 gram sample that is a mixture of calcium chloride and potassium nitrate. So basically what it's saying is, and I'm going to highlight this whole part, it's saying that we have this mixture of ionic solids. Okay, so we have this mixture of ionic solids. And as this question unfolds, what you're going to see is that we actually are interested in the calcium chloride. We're trying to figure out about that. We are not interested at all in the KNO3. The KNO3, the potassium nitrate, is like basically a contaminant. Okay, it's just something that we want to be able to eliminate and through titration determine how much of that actual solid mixture in the sample is made up of calcium chloride and not potassium nitrate. So anyways, we'll read on. It's dissolved in 50 cubic centimeters of water. The mixture is titrated with a 0.1 mole per cubic decimeter silver nitrate. There's actually a bit of a typo in here. It should say mole per cubic decimeter, as in dm to the minus 3. Silver nitrate. Silver nitrate reacts with the chloride ions present to form insoluble silver chloride, which is AgCl. And if it's insoluble, that means it's a solid as well. Okay, so we can put that there. The titration required 38.5 milliliters of silver nitrate. Okay, then it says write an equation for the reaction. So let's go ahead and do that. So we have the calcium chloride, okay, which since it's dissolved, it's going to be aqueous. We're mixing it with silver nitrate. 3 aqueous. Okay, and then that's going to react to make this insoluble silver chloride. That's going to be important for us. And it's going to make also the leftovers of that, right? Because here's the silver, here's the chlorine. What's left over is going to be calcium nitrate. So you have to put that calcium nitrate there too. Now we know that calcium has a +2 ion, so it's actually going to take 2 nitrates to balance that out. So the formula for calcium nitrate is going to be CaNO3 2. Now, one thing I glanced over is like, how do you know the formula of silver chloride? Oh, they gave it to us. I was going to say, if they didn't give it to us, we could use the fact that silver nitrate is AgNO3, and we could deduce that silver has a +1 charge if you weren't sure, but there we go. Now, like anytime you write a chemical equation, you want to make sure it's balanced. So have a look, is it balanced? You're going to identify, no, it is not, okay? And where it's imbalanced is actually in the chlorides. We need 2 chlorides here, so we have to put a 2 out front. That changes the silver to a 2, so we need a 2 out here as well. That's going to affect the nitrates, but the nitrates here, there's already 2 of them, so we are good. Okay, so that is your balanced chemical equation. So you'd get the marks for that guy. Now, one question I got from a student is, what happened in this process? What happened to the KNO3? Why is it like just gonzo and completely ignored? Well, that's because it is not reacting with the silver nitrate, basically. It is not forming any precipitate. It's not doing anything. So there would be K+ ions there at the start, potassium ions. There'd be more nitrate ions there at the start, floating around solution. And they would also be there in their exact same form at the time that the products were formed. So like, they really don't change. They don't do anything. So we exclude them. They're what we call spectator ions. Spectator ions. And actually, as a matter of fact, we could have done the same thing to the calcium ions and the nitrate ions. They are also spectator ions in this case. They don't really play an important role. They don't change chemically throughout the process. They just had to be there because to get an ionic compound, you have to have like the positive ion and the negative ion. You can't just add a single ion. That's not really like an entity that exists. They always come combined with another ion as an ionic compound. So anyways, that hopefully helps illuminate why we left KNO3 out of the equation here. All right, moving right along. We've got, then it says calculate the amount in moles of silver nitrate used in the reaction. Let's see if I can make a little space here for this. And maybe I can grab and move some of these bits and pieces. Let's see. Yeah, I can move these guys down and make a little space. Okay, so how much silver nitrate was used in the reaction? Let's go have a look up here. It tells us that we have this amount of silver nitrate. What is that? That's a volume. Okay, so the volume is 38.5 cubic centimeters. What else does it tell us about silver nitrate? It tells us this, 0.100 moles per cubic decimeter. Well, that is a concentration, right? So if we have volume and concentration, then we can use this formula N equals CV to find out how many moles there are, right? Using our what we know about solutions. So pump that stuff in to the equation. Now we got to make sure we get our units right. So we'll convert this to cubic decimeter. So 38.5, you're going to move it 3 steps. 1, 2, 3, 0.0385 cubic decimeters. And process that, you're going to get 0.00385 moles of AgNO3. Okay? So there's our moles of silver nitrate used. Alright, let's try and make a little bit more space here for the next part. Whoops, I'm making a bit of a mess of this, but trying to figure out how to use this. Calculate the amount in moles of calcium chloride titrated and the mass of calcium chloride present in the original sample. Okay, here's where we're going to use what we just figured out about the silver nitrate and apply it to the calcium chloride. Okay, so if we had this many moles of silver nitrate, we have to now look at the coefficients in the balanced chemical equation and say, how many moles then of calcium chloride are we going to get? We're going to get half as many moles, aren't we? Okay, because the ratio is, if you look at the coefficients, the ratio is 1 to 2, right? So if you just say, okay, I get it, I'm going to multiply that by a half, that's fine. I'm going to do it the laborious way and just show it with all the units so that if you're just looking at this and figuring it out, it's hopefully very clear. So the moles of calcium chloride are going to be equal to whatever the moles of AgNO3 were from above times the factor of 1 mole of calcium chloride for every 2 moles of AgNO3. So we're multiplying it by a half. Yeah. There we go. So half of 0.00385 is 0.001925 moles of calcium chloride. Da-da, da-da, da-da. Okay, now it says also, and the mass of calcium chloride. So now we just have to convert that into mass, okay? I'm gonna, let's see here, could I just slide this whole thing up to do that? Yeah. Okay. So mass, let's now figure this out. So the mass of calcium chloride is, we're going to have to use their formula, moles times molecular mass. There's the moles. Okay, the molecular mass is 111.1 grams per mole according to the periodic table. And the moles is right there, 1.92 times 10 to the minus, 123. 1.92 times 10 to the minus 3. Giving us a total mass of 0.214 grams. All right, then the final part of that, so there's our mass. Final question D, calculate the percentage of calcium chloride in the original sample. Okay, so we've got our mass of calcium chloride, 0.214, and we've got the total mass of the original sample. There it is back up there, 0.265. And we're just going to express that as a percentage. So you pump that in, you're going to get, it's around, I guess I should do the proper formula, it's times 100. It's going to be around 80.8% calcium chloride. Okay, hopefully that helped.